given. So we've been told that there's 2 points of inflection on the graph. We know that points of inflection occur when the second derivative, so f double dash x, is equal to 0. So we've been told the first derivative, so we need to find the second derivative. So 3 times negative 24 is negative 72 x squared plus 18x plus 3. We know that where the points of inflection occur when that's equal to 0. So negative 72x squared plus 18x plus 3 equals 0. We can now use our GDCs to solve this. So we're going to go into apps, number 4, and we're polyroot finder, so it's a polynomial order 2, and we're going to input our values. So that's negative 72, positive 18, and positive 3, and solve. So there we have our two values. So x equals 0.364 or negative 0.114. And that's all we have to do because it's the x coordinates. We don't have to give the actual points. Right, on to the next question. So a function has its first derivative given by that expression. Find the second derivative. So we're using the chain rule here because we have a function of a function. So the second derivative would be, the power comes in front, we have our bracket as normal, we take 1 off the power, we then multiply by the derivative of what's inside, which in this case is just 1, but I'm just showing the method. So we've got 3 bracket x minus 3 squared. That's that one done. And find f dash 3 and f double dash 3. So we're putting 3 into both of these two expressions. So f dash 3 would be 3 minus 3 to the power 3, which is obviously 0. And f double dash 3 is 3 lots of 3 minus 3 squared, which again is 0. Point P on the graph has x coordinate 3. Explain why P is not a point of inflection. You've actually got a couple of different options here. You can either look at the second derivative and see if that changes sign, or you can look at the nature of the gradient on either side. So I'm going to focus on the second derivative. We know we've looked at the second derivative when x is 3, so I'm going to look at the second derivative when x is 2. So if it was 2, it would be 3 brackets 2 minus 3 squared, which is 3 times 2 minus 3 is negative 1 squared, so that's a positive value. And if we look at on the other side, when x is 4, we have 4 minus 3 squared, which is 3 times 1 squared, which is also 3. Given that these are both positive, there is no sign change. For the second derivative, so it's not a point of inflection. Your alternate method could be to look at the first derivative. Again, we look at the derivative on either side of the point given. So if we're looking at either side of when x is 3, let's find f dash 2. Sorry, so it's x minus 3 all cubed. So 2 minus 3 all cubed is negative 1 cubed, which is negative 1. And f dash 4 is 4 minus 3 cubed, which is 1. Now, if we are looking at the sign diagram here, we've got a negative gradient on the left, we know it's at 0 at 3, and we have a positive gradient on the right. That clearly shows that the point is actually a minimum point and not a point of inflection. Had it been positive 0 positive or negative 0 negative, then we would have said it was a point of inflection. On to the next one. This was a tricky one, and I am sorry that I almost went through this with you in class. I did indicate that there wasn't enough information, but there actually is. So we've got a rectangular enclosure and we've told the area of it. So straight up, we don't know our measurements, but let's call this length x and this length y. We're told that x times y, in other words the area of the rectangle, is 525. From this information, we can actually find an expression for y in terms of x. So we know that this length here can be considered as 525 over x, and the other length is just x. Obviously we know this one is x and this one is 525 over x. So it says the fencing used for site AB costs $11 a meter. So we're now looking for an expression for the cost of the fencing. So if it's $11 a meter, that would be 11 times x. The fencing for the other 3 sides costs $3 a meter. So let me try and color code this. So for this side here, we're going to have 3x. For this side, we're going to have 3 lots of 525 over x. And for this side here, again, we're going to have 3 lots of 525 over x. Let's simplify this. So we've got 14x here plus, you've got choices here. Let's work out what 3 times quit. So 3 times 525, and then we've got 2 of those. So we've got 3150 over x. Okay, so I've just joined these 2 terms together. So that's an expression for our cost. We're trying to find the cost so it is a minimum. So in order to do that, we differentiate this. So because we're differentiating, first of all, we need to rewrite this in power form. So cost is 14x plus 3150 x to the minus 1. And differentiating that gives 14 minus 3150 x to the negative 2. It's a minimum when that expression equals 0. So 0 equals 14 minus 3150 over x squared. I'm going to bring this over to the other side, so 3150 equals 14. Bring my x squared up to the top. Bring my 14 underneath, and obviously now square root. So we are finding the square root. Oops. The square root of 3150 over 14. O over 14, which gives us 15. Obviously this is a plus or minus officially, but given that it's a length, we're looking at 15 meters. They've said what is the minimum cost, so they actually want to know the cost, so we're going to stick that value of 15 into the cost function. So 14x plus 315 over x. Oops, 15. So 14 times 15 plus, open bracket, three, 1, 5, 0 over 15. Oh. Gives 420, and this would be